Hello, this is Grapher, and we're going to look at plotting things like circles and also plotting simple uh, equations in a non-function format. First thing we're going to do is click on the plus symbol to add a new equation, delete the y equals, and I'm going to put the equation of a circle centered at 0, 0 with a radius of 5. X, shift 6 to get my caret, 2x squared, right arrow to get out of the exponent, plus y squared, right arrow equals 25, and there's the equation of my circle. Now, depending on your viewing window, just want to show you that potentially your viewing window makes it look more like an ellipse than a circle. So let's look at that. Suppose it came out looking like this and you wanted to equalize the axes so that it looks more like a circle. That's what this button up top is for. Alright, so we click on that and that will automatically, no matter how bad your viewing window was initially, will make circles look like circles and squares look like squares. Alright, what I'm going to do now is take the check mark off that and look at a more non-traditional use of this feature. I'm going to add a new equation. I'm going to delete the y equals, and I'm going to put in 2 times the quantity x squared plus 3 outside of the parentheses equals x squared plus 10. Okay, so this is in one variable, therefore it is going to be either one or two vertical lines, and students will be often asked to simplify this. So there's the solution, and if they go through some steps in simplifying, let's show what some of their steps might look like. Their first step would probably be to distribute the 2. So after the first step, it would probably look like 2 times x squared is 2x squared. 2 times the 3 is 6 equals x squared plus 10. And what they can do is click back and forth, click these on and off, and sometimes we even like to change the color of the original. So I'm going to click on this one and go to my inspector and make this red, and also make it nice and fat or wide. And I'm going to close this. And so basically, if these two steps are equivalent steps, then the graphs should be right on top of each other. All right, and it appears to be that way. All right, going on, they might now subtract x squared from both sides. So their next step might look like x squared plus 6 oops, got to get out of the exponent first, plus 6 equals 10. And that would be subtracting the x squared from 2x squared. And again, we can verify that the first step in red and this last step in black is in fact an equivalent visual picture. Alright, finish this off by subtracting 6 from both sides. So they would probably have x squared equals 4. And again, the original and the new one basically are the same graph, and therefore we have an appropriate step. If we want to go one more step, we could simply add and say, okay, from there I get x equals 2 or x equals negative 2. And again, you can verify that these match the graph of the original, And now basically what you've done is created, if you're going through all this work, students will often take a screenshot of their equations, Control-Shift-Command-4. I'm just going to repaste it right on my graph, but they could be pasting it into a Word document, and that way they have basically an equation editor type view of their work. All right, so especially if there's an error in a multiple step problem, this is one way that they can visually verify that their steps as they go through the procedure are in fact equivalent. This was Grapher plotting freeform, and using Grapher as a way to show multiple steps in solving an equation or simplifying an expression.